Insulators have their own advantages. They are generally used as the protective covers of these conductors. That means if you consider a copper wire, so this copper wire, if you touch, means when the current electricity is flowing on, we may get shock. Okay. So in order to prevent this, these electric wires are covered, plated with by the help of insulators like rubber, plastic and all to protect ourselves. Okay. And one more thing children, even non-metallic substances like diamond, graphite, even though both diamond and graphite are made up of carbon elements only, graphite is a good conductor of electric current, whereas diamond is a bad conductor of electricity. So diamond is a non-conducting material, whereas graphite is a conducting material, even though the composition of the both are same, that is carbon itself. Not only this children, substances like water, if you consider, pure water is a non-conducting, is an insulator. Pure water is an insulator, but impure water is an, like impure water means some salts are added or something else is added. Impure water is again a conducting material. Distilled water, pure water means distilled water is an insulator, whereas so other distilled water is a conductor, insulator. Distilled water is an insulator, whereas impure water is a conductor. Not only impure water, like acids or also you can consider it as conductors. So children, let us continue with the numerical part of this exercise. So let us move to the level 1 questions. The rate of flow of electric charge measures electric current, isn't it? So the rate of flow of electric charge measures current. So hence the correct option is option B, that is current. Rate of flow of charge. Charge flowing per unit time is called as current. Next one, the condition for an electric charge to flow from one point to other point between the two must maintain. So one point is the another point between these two. So what is being maintained children? Potential difference is being maintained. So the correct option is option C, potential difference. Third question, the device that maintains electric potential difference between 2 points is called as. So what is the device that maintains the potential difference children? That is cell. Okay, the correct answer is cell. Now the next question, fourth one, the path connecting 2 points at 2 different potentials to make the electric charge flow. What is that path? That path generally it is called that electric circuit. Okay, cell is there and the path, like this electrons are flowing in the wire. So that path itself is called as your electric circuit. Here circuit, simply circuit they have given you. So option A is correct. Now the fifth one, 1 ampere is equals to, 1 ampere is equals to how much children? 1 ampere is equals to number of, how many microamperes? You know, micro means 10 power minus 6, micro means 10 power minus 6. So 1 ampere can be written as, let me write it as 1 into 10 power minus 6 into 10 power plus 6 ampere. May I write it as like this? I have subtracted 10 power minus 6 and 10 power plus 6. Minus 6 plus 6 is 0. So 10 power 0 is 1. So there is no difference. So I have added 10 power minus 6 and I have removed 10 power plus 6. So 1 ampere can be written as this 1 into, let me write it as 10 power 6 into this 10 power minus 6 amperes. But what is 10 power 6 minus 6 children? Yes, this can be written as 1 into 10 power 6 into 10 power minus 6 itself is nothing but micro. Hence, 10 power minus 6 amperes can be written as micro amperes. So, what is the total value children? So, 1 ampere can be written as 10 power 6 micro amperes. 1 ampere is equals to 10 power 6 microampere. Hence, option 1 must be true. So now to the next question. Sixth one, how many electrons constitutes a current of 1 microampere? We know that the current is defined as charge upon time. The rate of flow of charge is called as electric current. And very beginning I told you that charge is equals to number of electrons per unit time. So current is given as 1 microamperes must be equals to number of electrons. Electrons, the charge of electron is 1.6 into 10 power minus 19 upon unit time means 1. So what is the value of 1 microamperes? If you convert in amperes, it will be 10 power minus 6 amperes. 1 micro is taken as 10 power minus 6 ampere because they gave it as microamperes equals to n times of 1.6 into 10 power minus 19. So let us bring this 1.6 into 10 power minus 19 to the left side. Then how much it will be, children? So 10 power minus 6 upon 1.6 into 10 power minus 19 is equals to n. Okay. So well, bringing this to the other side, 10 power minus 6 into 10 power plus 19. Minus 19 goes up means will become plus 19 upon, because I removed this, upon 1.6 is the value of your n. Hence, minus 6 and plus 19 will become, so 10 power 13 minus 6 plus 19 is 13, nothing is there, let me add it as 1. So 1 into 10 power 13 upon 1.6 can be written as 10 upon 1.6 into, so this one I made it as 10, so I have to reduce the power as 1, that is 10 power 12. 1 I given to the other side. What is the value of 10 upon 1.6, children? If you simplify, it will be something like 6.25. If you divide 10 upon 1.6, you may get approximately 6.25 into 10 power 12. So, how many electrons? N indicates the number of electrons. So, 6.25 into 10 power 12 electrons will constitute a current of 1 microampere. Hence, the correct option is option B, that is 6.25 into 10 power 12 electrons. Moving to the next one, seventh one, electric current is produced by the rate of flow of charges. What are the charges here? Because the electrons are moving, protons are not moving. Conventionally we are considering it as proton. The electrons are moving. Flow of charges means flow of electrons constitutes the current. Hence the correct option is option A, that is electrons. The eighth one, direction of flow of conventional current. Earlier flow of electrons constitutes the current, but here conventional current means what should come into your mind? It is protons. Let us see. Direction of flow of conventional current is taken from where to where? Okay, conventional current means it starts from positive and goes to negative. So where is that? Positive to negative, option B. Well, the next question. Materials which allow larger currents to flow through them are called as, which one allows the flow of current? Which is a good conductor? Sorry, I told you. Okay. So, conductors allow the charges to flow through them, whereas insulators will not allow the charges to flow through them. Okay. Metals are good conductors. So, electrons, there are large number of free electrons to constitute the current. Semiconductors means it is a different topic, partially they will allow. Okay. So, the materials which allow large current to flow through them is nothing but your conductors. The best example is metals. So, option B is correct. Now, the next one, 10th. Conventionally means positive. The direction of the current is taken as the direction of which one? Positive charges. Hence, option D. Conventional means positive charges it starts from. Well, the 11th one, good conductors have many loosely bound. What are they? Electrons. What are they? Electrons. Conductors have large number of free electrons. Now, the 12th one, in a conductor, the flow of current is conductor. Who flows? Obviously electrons will be here. Only when convention is used, you have to consider it as in the other way, that is from positive one. If no convention word is used, only because of the electrons, flow of electrons. So option B. Now moving to the level 2 questions. If I is the current through a wire and E is the charge of an electron, then the number of electrons in t seconds will be. I already told you the formula, children. Current I is equals to number of electrons, charge of electrons. Okay, overall electrons means the number of electrons. This is the formula I already used. I is equals to Q by T, or I is equals to number of electrons upon time. So I is the current they have given us, E is the charge they given, and also T is the seconds they have given. You are asked to find the number of electrons. So number of electrons indicated with the letter N. So N can be written as I, bringing the T other side, IT upon E. So N is equals to IT upon E. So the correct option is the fourth option, that is IT upon E. Now the next one. In a conductor, 4 coulombs of charges flow. How many coulombs, children? Coulombs is the unit of charge, Q. And charge flows, time is given as 2 seconds. T is 2 seconds, the value of electric current. Of course, the value of electric current is equals to Q by T. You are asked to find the current. Charge measured in coulombs. How many coulombs they gave? 4 coulombs upon time is 2 seconds. So if you simplify this, it goes upon 2 times, and hence the current is found to be 2 amperes. Current is measured in SI units of current is amperes, 2 amperes. Hence, third option is true. Now, the next last question, children. A rheostat can be used in an electric circuit. What is a rheostat? Let me show you how a rheostat looks like. So, this is the picture of a rheostat. So, this rheostat generally consists of 3 terminals. Terminal 1, terminal 2, this one, and terminal 3. 3 terminals. So, these 2 terminals generally maintains the potential difference. The one is positive terminal, the other is negative terminal. So, which is connected in the circuit. Whereas, this can maintain a constant. Some resistance can be applied with the help of. So, how much resistance? So, 1 ampere, 0.1, 0.2, a small resistance can be applied through this shifting device. So, actually it has 3 terminals, and these 2 terminals maintain a potential difference. Okay, even though this apparatus is used to measure the electric resistance, but still this will maintain some potential difference. Hence, it can also be used as a potential divider, but rarely it will be used as a potential divider. For that, to maintain the potential divider, we have another instrument called a potentiometer. Thus, that you will be learning in the higher classes. So, until now, this is the picture of a rheostat used in the electric circuits to maintain some constant electric resistance. But as it consists of 3 terminals, these 2 terminals are helps us to maintain some potential difference. Hence, the question, a rheostat can be used in an electric circuit as a, which one? Standard resistance? Not a standard. This is not a standard, variable resistance, because it is been varied. Whenever we are shifting this device, the resistance can be varied from 0.1 ohm, 0.2 ohm, 0.3. So, resistance can be varied. So, variable resistor, not constant resistor. Okay. Potential divider, yes, of course, not about heat or on and off switch. So, the correct answer is option number B, that is potential divider. That's it, children. So, with this, let us conclude our today's topic. So, let us meet in the next video. So, until then, keep practicing, children. Have a nice time. Thank you.